So now that we've been introduced to sinusoidal curves, next thing I want to discuss is applying dilations to those, either stretching or shrinking. Now, first off, algebraically, what we are going to see is something being multiplied onto either the value of the sine function or the value of the cosine function, or x itself. So the two quantities in question are going to be referred to as capital A, and this right here is the Greek letter, the 24th Greek letter, omega. This is to stay consistent with what we see in our textbook. Now, since both of these fall into the category of stretching and shrinking, I just wanted to let you know how these have an impact on the graph. Now, vertical stretches and shrinks are going to have an impact on the amplitude. Now, the term that I like to use for this is amplitude modulation. I realize that in the era of all sorts of music listening apps and podcasts and whatnot, that some people don't really listen to the radio anymore. I will let you know that amplitude modulation is what the AM in AM radio stands for. We're going to do that in our problems as well. Now, the way that it has an impact on the amplitude is that we are going to be multiplying y, or all of our corresponding y values, by whatever that value of a is. Now, this works even if a is negative. That just means that there would be a reflection with it as well. However, when we refer to an actual amplitude, we are referring to the distance. Therefore, we would want that to be equal to the absolute value of a. So if you are supposed to identify the amplitude of a sinusoidal graph without necessarily graphing it, take the absolute value of whatever the initial coefficient is. Now, the impact that omega has messes with the wavelength, or the period. That is going to give us what I refer to as frequency modulation. Frequency is a quantity that is tied to the length of a wave, and it is the FM of FM radio. Now, horizontal transformations tend to do the opposite of whatever you see. I see omega times x, so the way that we would solve for x is to divide your x values by omega. Now, with that in mind, one period is typically going to go from, have a length of 2 pi divided by omega. There is a slightly different mindset that I like to get into for this, and I'd like to show you that mindset. When we think of the first period of a sine or cosine curve, generally what we think of is one full revolution on the unit circle, going from 0 radians to 2 pi radians. Now, our angle is supposed to go from 0 to 2 pi. The angle of a trigonometric function is simply whatever you're inputting to the sine or the cosine. So what I would do is have you say, put omega x inside of here, and then use algebra to solve for x. Whatever algebra you do to solve for x is going to be the same thing as the frequency modulation that you're going to be performing yourself. So 0 divided by omega, omega x divided by omega, and 2 pi divided by omega lets us know that a period will start at 0 and it will end at 2 pi over omega. The idea is this 2 pi over omega will be the same as this 2 pi over omega, and that should work out pretty nicely.